Hello and welcome to our webinar on using virtual points in ProAnalyst. My name is Patrick Hope. I am a product marketing specialist at Excitex here, and I'm just going to begin the talk in just 1 minute. So this discussion is on the use of virtual points within our software. And today I'm going to go over and discuss what, in fact, virtual points are. We're going to talk about some of the types of virtual points that can be used within the software, and I'm going to provide a few examples of virtual points in use using videos from applications that we've encountered and just some common uses of virtual points themselves. So the general idea behind virtual points is that they are points that exist within the 2D environment that are not tracked features. So these are points that we're bringing into our 2D feature tracking, which is the most common toolkit of ProAnalyst itself, but they are points that have been brought in outside of the features themselves. These virtual points can be interacted and they act just like normal 2D features. And so because of that, we can use many of the same calculations that we would use for a normal tracked feature on these virtual points. And one of the interesting examples and benefits of using a virtual point is that they are not bound within the existing window. When you're tracking a feature, your feature is limited to the available screen size. A virtual point can actually go outside of the visual screen, and this is useful in rigid body studies where a rigid body is moving around and perhaps a portion of it leaves the screen. We can use a virtual point to recreate the position of that point relative to other tracked features, and we can still follow its motion as it disappears from view. So let's now talk about some of the types of virtual points that we're able to bring into the software. And there are two basic types of virtual points that can be used. The first virtual point that can be used are essentially imported points. These are points that are taken from some of our other toolkits. And we could take points from a 1D line tracking toolkit, and in this instance we convert the physical point that's pulled off the 1D line into a 2D feature toolkit and make it a virtual point. We can also import information from particle tracking toolkits. In this instance, the correspondence trail for the particle becomes the feature that you are tracking, and it makes up the virtual point. And then the last place that we can import virtual points from is from our contour tracking toolkit. And in this, we can import the center of mass of the tracked contour as a virtual point. So in this example, this is bringing a virtual point in from a 1D line tracking tool. So here we could see we have several 1D points that are tracked. What they do is they track this knife edge blade. Well, we can compare that to this point down here, which is not a virtual point. And what happens is we can bring in multiple of these 1D points, in this case 0.5 and 0.1, and we can make these into virtual points. And they exist as virtual points because we see the VP next to the point itself. And so then we can compare these two pre-existing virtual points that came in on 1D to a location tracked in 2D. And in this instance, we compare via an angle measurement. So we can measure the angle over time of 1D line points versus 2D feature tracking points using virtual points. So the other way that we can import points, like I said, is through particle tracking. And this is a still from one of our shots where we're tracking the motion of these particles through space. So they start at a location and they go to a destination. And we've picked up multiple points here. In particle tracking, the way that the points are organized aren't by numbers specifically. They're based on these correspondence trails. So what we end up doing is we end up converting a correspondence trail into a point. In this instance, we've converted correspondence trail 6 into a virtual point, and we've tracked that across the field. This is an excellent way to bring in and very quickly analyze a lot of data. If you have a lot of fragmentation, you can convert all of the particle tracking points that you would be getting out of that fragmentation into virtual points and bring them into a 2D field. And then subsequently, if you have a binocular view on this, you can input and import those particle tracking points into two 2D shots, and then likewise bring it into 3D via virtual points. And that makes the whole tracking system easy, as you are basing it on correspondence trails instead of physical points. And so it is easier to track those points over time. And the last example here is with contour tracking. And in this instance, we have brought this contour in, and we have tracked this, and we find the center of this contour, and we can set it as a virtual point. It's pretty straightforward. Not much else needs to be said in terms of that, but it's a central point based on the area of the contour. So the second type of virtual points are calculated points. And whereas the other ones were imported from a measurement that are made, these calculated points are based on existing points or features within the video. And these are used to get a better idea of the motion within the video and to simplify some of the things that we are seeing. And I'll go through the list of them here. The first one and most basic one is a midpoint finder. And all that does is that creates a virtual point between two pre-existing points. So if we have a feature point here, point 1, and a feature point here, the midpoint just literally finds the exact instance, the exact middle point between them. In this instance, I've drawn a line here, but the physical line doesn't exist. The point just sort of hovers in blank space. So the second type of point is a proportional distance along the line virtual point. It's very similar to the midpoint finder, but almost in reverse, where we have two initial points, and then we create an offset of one point along, again, this invisible line that exists here. This can seem a little bit strange to find and tough to calculate, but with all of these points, we have a use current reticle point feature, so that we target the location, or we would target the location where we want the virtual point to exist, and then we click the use current reticle point, and by doing that, the software calculates the proportional distance that exists along this line, so you don't have to come in and form the calculation itself. You could set this value to be an integer value, so it could be 2 or 3 or whatever the relative distance is that you'd like, or you can use the reticle finder to just pinpoint the spot. Another type of virtual point that is calculated from other points is the circle fits center. And in this, we take 3 points, and what it does is it generates a perfect circle fit, and it puts your virtual point as a central point for those 3 points. This can also work in conjunction really well with 1D line tracking. So if I have these points can be generated from 1D lines that go like this. Oh, let me just head back real quick. And we can convert these 1D line points into 2D points. as virtual points themselves, and then we can bring in a virtual point as the circle fits center on top of that. Points upon points. We also have a fixed offset that, again, we use the current reticle point to find the location of this. The idea behind the fixed offset virtual point is that we start with a single initial point, and we set X and Y pixel values to offset that point. This is only going to work out when you have motion within a flat 2D plane that is not rotational, but it is a way to offset the point for a rigid body based on these two values here. And again, we could just click the use the current reticle point button to generate this virtual points location. Another excellent tool when we're dealing with rigid body is the rotation and distance offset. Now this is different than the previous example in that there are 2 points here. And so these 2 points exist along a rigid plane, and these 2 points can rotate relative to one another. And what you do is you use your current reticle point to set your offset virtual point here. And then in this way, as these points are manipulated and as they move laterally around the field of view and around the plane that is calibrated, your virtual point will stay in the same relative position. And again, this is very useful for rigid body because it allows this virtual point to go off the screen and to hit a point that isn't any longer within the video. And so in that way, you can see how objects are interacting with one another as they aren't even visible on the video. Another type of calculated virtual point is called a 4-point angle join. So we have this feature within our line drawing tool where we can connect 4 points into a 4-point angle. And this is great for body reconstruction and whatnot, where if this was the leg of the individual, we would be setting an angle value and giving an angle value here based off the knee point. Well, just like that generates the angle based on these 4 points, the 4-point angle joint creates a virtual point at that non-existent intersection of the angle here. There is no use the reticle on this because you're using absolute point values for this. So there's no need to generate that. Another very interesting and very powerful type of virtual point that we have available is called the pixel intensity value point. This is generated with the reticle as well, and in it you essentially assign a value to a single pixel, and then you output intensity RGB values off of that single pixel using the intensity value virtual point. So this can be a way to find strobing effects and find the luminosity or the intensity value of a point if it is changing throughout the video. So I've got an example of that later that will help to demonstrate the use of this virtual point in more depth. And then the last one is from data graphing. And what this does is this generates a virtual point based on information and data gathered from the XY positions of a graph data. So in this instance, we have 2 graphing values here. And what it just does is it creates this floating virtual point, and it gives, for instance, in this instance, the X value is generated from our pink line here, and our Y value is generated from the blue line. So you can filter point lines and generate points based on filtered graph information from other points. Now I'm going to spend a few moments here, if you can bear with me, and we're going to go through a few examples that will hopefully illustrate these examples a little bit better and give you a better idea of the capabilities of virtual points. So this first example is the use of an offset rotational and distance offset. So we have two locations on the gun which we've tracked here, which are feature points. Just turn this off. So point 1 and point 2 that we follow through on the processed video. Let me look at the raw one here. And what we've taken up is we've taken and created the barrel of the gun as the virtual point. And as we play the video through, you can see that these 2 points relative to each other, because they're on a rigid body, they rotate and they move relative to each other, and our virtual point will stay in the same position relative to them. And so in this way, we're able to bring a point off of the screen of the video using a virtual point. So to access the virtual points, it's a part of the feature tracking. You generate a new point and then you open up the settings on this. Within the settings for the feature tracking point, there is another sub window called virtual point. To set those, we click the set button here. And in this instance, we have the rotation and distance offset selected for feature 2 and feature 1. If we want to, we can come back here and we can generate an additional virtual point based on the offset of feature 1 and 2. And then I can just pick the point using my reticle here, and it generates the points for that. So that when we close this out and we track this through, it again will show the rigid structure for that point. And because of the position, it still goes off the screen as well. This is an example of particle tracking. So we've generated these particle lists inside the software, and they're following these objects as they pass over. This is a sea anemone that's eating these particles and filtering them through. And so we can convert any one or all of these points if we want to virtual points and bring them into 2D and analyze their motion individually. If we leave them in particle tracking here, then all of the data that we're outputting is outputting them as a whole, as a communal data points. What we do is we can turn on what's called the correspondence trails. Those are typically turned off by default. And as you can see, we have correspondence trails for individual points coming through here. So I have a correspondence trail for what is labeled as particle 104. If I want to generate a virtual point for that, I can come into my feature tracking, turn on the feature tracking and make sure there's a point added. I open the settings wrench and I click on virtual point. I can bring that from particle tracking, and I believe it was 104. And as I apply that, we have now created a point out of that particle tracking point, just like that. And I could do that. I could do that individually for each of these points if I would like. And it tracks it along the whole length of the particle in itself. This is an example of a 4-point angle joint. So this is a very common example where we want to check out the angle of the leg during a crash test. So as I zoom out, you can see that this is a crash test dummy. And so what we can do is we can recreate a line in within the 2D feature tracking that creates a 4-point angle between there to measure this angle. Well, we can also come in here into the virtual points, and we could set a virtual point to just determine that. We just have to set up the angle joint exactly identically to how we do it in our feature line toolkit by setting the first, second, third, and fourth feature like that. And the end output is a virtual point that exists here, this VP, in space, which represents the 4-point axis for that angle. This is an example of incorporating multiple virtual points from multiple different tools. This uses 1D line tracking, contour tracking, and the circle fit center virtual points. So I'll break these down individually one at a time to sort of explain how these have been combined all together. The first thing that we can see going on here is our contour tracking toolkit has followed this this contour of the heart valve. So this is an artificial heart valve that is opening and closing. And so we've measured it essentially in two ways. We've measured the open valve as a contour to track the area of it, but I've also used 1D line tracking to create these lines here to give a general overall average circular value to the opening as well. So because of that, there are multiple ways that we can measure something. So in this instance, if I was interested in what the central point of the heart valve is, I can measure that central point in two ways. I can come in here and I can generate a virtual point based on just the center of the contour here. But in addition to that, I can generate a virtual point based on the center of the average circle that we have of the opening. And we can watch how those two virtual points interact. So the first virtual point that we've set here is just from contour tracking. And there's just a single contour that exists here, so we just label that as contour 1. And that generates our first virtual point that's going on. The next virtual points that have to be generated, if I want to come in here, I have to import these 1D line tracking points into being 2D virtual points. And so to do that, I open up the virtual point settings, which is inside the feature settings, and I just select from line tracking. I have 3 lines in here, so I need 3 points. Line tracking 1, 2, and 3. And if I open these up, these will all have the unique line tracking values on them. And then the final virtual point that I'll bring in here is a virtual point that is a circle fit center for these 1, 2, 3 feature points here. Now these 3 all happen to be virtual points that came in on the 1D virtual points. So they're generating a virtual point from all that 1D graph information here. And then we can, if we zoom in, we can see the difference in location between those 2 virtual points. So this being the virtual point center from the contour tracked, and this being the virtual point center from the 1D line tracking. And then the last example I have here is for pixel intensity value. And so this instance, this is a tattoo machine that's measuring the motion of the this metal element in here, and I've tracked this using 2 virtual points in 2 different ways to just show you how this works. One of the virtual points is tracked via pixel intensity value. Here, they're both tracked via pixel intensity value. One is tracked via the pixel intensity value of the raw video, and then the other one is based off of process video, which would look similar to this. So we can track the pixel value here, which will be sharp, basically binary 0 and 1 values, versus, as we said it here, which will be more of a gradient view through the pixel intensity. And again, to set the point, we just use our reticle to determine the location of this. So when we come in and when we graph it, we can graph our Y values for these 2 virtual points. And there you go. We get pixel intensity values. So the red ones represent the heavily contrasted. So it's basically giving us values of 0 and 255, 0 and 255. And then the green ones represent the ones where there's some sort of gradient, where we're not quite reaching fully black and fully white. But by as I turn this off, that basically gives us the yes-no gradient for the motion of this, for when the object is touching and when the object is not touching in there. And then we can output that graph to get more logical data, or we can filter the graph to just, as I said, make it a 0-1 binary graph showing the motion within the pixel intensity. So those are the examples showing several of the more common types of virtual points that are available. So today we covered some information on the use of virtual points within the software. We talked about how virtual points interacted with 2D features, in that virtual points are very similar to 2D features that are tracked and can be interacted with in the exact same way. We also talked about some of the general types of virtual points, and there are two general types of virtual points: those that are imported from external toolkits, and those that are calculated based on values inside the 2D feature tracking toolkit. And then I went over a few examples that we had. If you're interested in getting more information on virtual points or any other part of ProAnalyst and would like some more information on that, please feel forward to reach out to us and visit our website. We have a wealth of knowledge available there, and we would be happy to help you out with this application or any other application that you are looking at doing. Thank you very much for your time today. I really greatly appreciate it. And I hope you have great success integrating this into your applications in the future. Thank you. Bye-bye.